This is our first lesson in Saxon's Algebra 1. In this lesson, we will review addition and subtraction of fractions, and we will also review the notation for lines and segments. We shall start with a question. What is 1/2 plus 1/4? Well, the meaning in terms of circles is you have half a circle plus 1/4 of a circle, and that gives the configuration you see there. The trick to this problem is to subdivide each of the circles into the same number of pieces. The first half is 2/4, and the second half is 1/4. And so when you add them, you end up with 3/4 of a circle. In other words, you have to rename the half to 2/4. Another question. What is 5/6 minus 1/4? If we divide a circle into 6 pieces, 5/6 looks like this. But 1/4 looks like this, so we have to divide the circle into more pieces in order to represent the 1/4. Therefore, we divide the circle into 12 pieces, and 5/6 looks like this. In other words, 5/6 is 10/12, and 1/4 is 3/12, so we have 10/12 minus 3/12, and that gives us 7/12. These examples illustrate 3 rules for adding and subtracting fractions. The first rule is that fractions can be added or subtracted if they have the same denominators. You just add or subtract the numerators. For example, 5/11 plus 2/11 is 7/11. You just add the 5 and 2. 5/11 minus 2/11 is 3/11. 7/12 plus 4/12 is 11/12. And 5/6 minus 2/6 is 3/6. Our second rule is that fractions can be renamed by multiplying or dividing numerator and denominator by the same whole number. For example, 1/2 can be renamed to 2/4. We multiply top and bottom by 2. 1/4 can be renamed to 3/12 if we multiply top and bottom by 3. 8/12 can be reduced to 2/3 if we divide top and bottom by 4. If we combine these 2 rules, we get a third rule, which tells us how to add or subtract fractions with different denominators. To add or subtract fractions with different denominators, we must rename them so they have the same denominators. For example, 1/3 plus 2/5. Here we have to rename both the 1/3 and the 2/5. A common denominator is 15 because both 3 and 5 go into 15. So we will multiply 1/3 by 5/5, and we will multiply 2/5 by 3/3. This gives us 5/15 plus 6/15, which is 11/15. Another example, 5/6 minus 1/4. We want the least common denominator. Both 6 and 4 go into 12. So we will choose a denominator of 12. Multiply 5/6 by 2/2, and multiply 1/4 by 3/3. This gives us 10/12 minus 3/12, which is 7/12. A final example, 7/12 minus 1/3. Since 3 goes into 12, we only need to multiply 1/3 by 4/4 to make it into twelfths. This gives us 7/12 minus 4/12, which is 3/12. But 3/12 can be reduced because both 3 and 12 are divisible by 3. So we get 3 divided by 3 over 12 divided by 3, which is 1/4. Now we will look at mixed numbers. A mixed number is the sum of a whole number and a fraction. Sum means you add. For example, 13 3/5 means 13 plus 3/5. When we add and subtract mixed numbers, we handle the fractions and the whole numbers separately. Here are some examples. 13 3/5 plus 2 1/8 means 13 plus 3/5 plus 2 plus 1/8. We separate the whole numbers and the fractions. This gives us 13 plus 2 plus 3/5 plus 1/8. 13 plus 2 is 15. And in order to add 3/5 and 1/8, we must get a common denominator. 3/5 is 24/40, and 1/8 is 5/40. So we have 15 plus 24/40 plus 5/40. This gives us 15 plus 29/40, which is 15 29/40. As a second example, consider 7 3/4 minus 2 1/6. The 7 3/4 is 7 plus 3/4. Since we're subtracting 2 1/6, we have to write minus 2 minus 1/6. So we have 7 plus 3/4 minus 2 minus 1/6. Taking the whole numbers, we have 7 minus 2, and the fractions, we have plus 3/4 minus 1/6. 7 minus 2 is 5, and to handle the fractions, we need a common denominator, which in this case is 12. So we rewrite the 3/4 minus 1/6 as 9/12 minus 2/12. This gives us 5 plus 7/12, which is 5 7/12. We must also consider borrowing. When the fractional part of a mixed number that is being subtracted is larger than the fractional part of the number it is being subtracted from, we have to borrow. For example, if we need to subtract 1 3/4 from 5 1/4, we have 5 plus 1/4 minus 1 minus 3/4. But we cannot do 1/4 minus 3/4 because 3/4 is bigger. So we change 5 to 4 plus 1. That gives us 4 plus 1 plus 1/4 minus 1 minus 3/4. But we can rename 1 as 4/4 and then combine it with the 1/4. In other words, we have 4 plus 4/4 plus 1/4 minus 1 minus 3/4, and that can be rewritten as 4 plus 5/4 minus 1 minus 3/4. Now we are in a position that we can subtract the fractions. We have 4 minus 1 plus 5/4 minus 3/4. That gives us 3 plus 2/4, but 2/4 can be reduced to 1/2, so we have 3 plus 1/2, which is 3 1/2. Our next topic is lines and segments. A line in mathematics is an abstract idea. It goes on forever, is straight, has no width, and no ends. To show the location of a mathematical line, we draw one through at least two indicated points and place arrowheads on both ends, like this. We designate this line as AC with an arrow over it. The overbar with the two arrowheads tells us it has no ends. When more than 2 points are indicated in the drawing of a line, we can name that line in many different ways using any of those 2 points. For example, there are 6 ways we can name the following line. They are line AX, line XA, line AC, line CA, line XC, or line CX. A segment is a part of a line containing 2 endpoints and all points between them. We name a segment by naming its endpoints and using an overbar without arrowheads. Every segment can be named in 2 ways depending on which endpoint is named first. This segment can be named as MC bar or CM bar. When we do not use an overbar, we mean the length of the segment. So MC without the bar and CM without the bar both represent the length of that segment. When a segment is split into 2 smaller segments by a point between its endpoints, the lengths of the smaller segments add to the length of the whole segment. In this drawing, AX plus XC equals AC. That is, the lengths of segments AX and XC add to the length of segment AC. Here are some sample problems. If PQ is 3 2/3 and QR is 1 5/6, find PR. In other words, we're given the lengths there of PQ and QR and asked to find the length of PR. The solution is to use the formula PQ plus QR equals PR. So PR is 3 2/3 plus 1 5/6. Okay, we have to rename the 2/3 so it becomes 4/6. Then we can add 3 4/6 and 1 5/6. That gives 4 9/6. But 9/6 is an improper fraction, so we think of it as 4 plus 6/6 plus 3/6, which is 4 plus 1, because 6/6 is 1, plus 1/2, and that gives us 5 1/2. Here's another example. Segment AC measures 10 3/8 units. Segment AB measures 4 5/6 units. Find the length of segment BC. The solution is again to use the formula AB plus BC equals AC. So BC is AC minus AB. That gives us BC is 10 3/8 minus 4 5/6. We need a common denominator. Both 8 and 6 go into 24. So we rewrite 10 3/8 as 10 9/24 and 4 5/6 as 4 20/24. But 9/24 is smaller than 20/24. So we borrow 1 from 10 and add 24/24 to 9/24. That gives us 9 33/24. So we have 9 33/24 minus 4 20/24. which gives us 5 and 13/24. Here's another example with fractions. Find the value of 5/11 minus 1/6 plus 2/3. The denominators of these fractions all go into 66. So we rename each fraction with this denominator. For 5/11 we need to multiply top and bottom by 6. For 1/6 we need to multiply by 11 over 11. And for 2/3 we need to multiply top and bottom by 22. This gives us 30/66 minus 11/66 plus 44/66. Well, 30 minus 11 is 19, so we have 19/66 plus 44/66. And 19 and 44 is 63. So now we have 63/66. Both 63 and 66 can be divided by 3, so we reduce this fraction to 21/22. That's all for this lesson. But it is very important that you practice these concepts by working all the problems on page 3 of your book. Follow the daily assignments in this course. You cannot learn math if you don't practice it on a daily basis.